Hello and welcome to another episode of Study Session for AP Calculus BC. And in this video, we will be covering basic derivative rules or whatnot. And there will actually be a second video on this, hopefully coming out later this week. It's a big chapter, so there's a lot to cover. I can't get through all the examples in one quick 15-minute or 16-minute video. So that will be the case. So if we first start off with, so our first rule is called the power rule. And then first, sorry, that E was pretty bad, and so I'm just gonna quickly decrease my size or my brush size. So the power rule essentially says that if we have something we want to take the derivative of, so like let's say we wanted to take the derivative of y equals x squared for any value of x, which we'll just say that we're taking the derivative of the variable x. For any value of x, the derivative of that will be, so for any x to the n, the derivative will be equal to n x to the n minus 1. Okay, so if we call this f of x, f prime of x, which essentially says the first derivative of x would equal 2x, because we take the 2, we put it out there, and then 2 minus 1 is x to the first, so we get 2x. So another example, and the derivative of any constant, if we were to say 2x plus 3, will be equal to 0, because if we think of 3 is really 3x to the 0th power, and because x to the 0th power will be 1 for any value of x. So 3 times 0 is 0. 0 times x to the negative first, but 0 times anything is still 0. So the derivative of a constant is always 0. Okay. So the next rule we have is the product rule. And the product rule essentially states that if you want to take the derivative of u times v will be equal to u times dv dx plus v times du dx. And what this essentially says is that the derivative of this will be equal to u, so whatever u is, times the derivative of v plus v times the derivative of u. So if we are going to quickly write a quick example of this, if we had, let's say, 3x times 4x or whatnot, we could say that the derivative of this, and of course we could multiply this out, and we'd end up with 12x squared. We should expect 24x. Okay, so let's actually work through this. So 3x would be our u times the derivative of v, which would be 4, plus 4, which is 4x, which is v, times the derivative of u. This equals 12x plus an additional 12x equals 24x. So that is the product rule. And our third rule is called the chain rule. And what the chain rule essentially says is that du, that's a u, over dx times dx over let me make sure I have this right, because I believe I remember it, but just in case I don't remember how it's actually wrote out, I want to make sure that I'm writing it. Okay, so so yeah, I was writing it out. Okay, so if you want to find, I was actually skipping a step, so I'm going to go ahead and just quickly clear this. Okay, so let's say we want to find dy over dx. So that's essentially the derivative of x with respect to y. We can rewrite this in terms of u and v as dv, or I'll call that du actually, du over dy times, or sorry. Completely disregard what I was talking about. I know the application of the chain rule, but it's writing it out in this formula. I don't have it memorized, and I probably should, and I will after this video because I messed up a ton, but it's okay. So it's equal to dy over dv times du over dx dv over dx. Did I call that du? I accidentally said du. And basically, the principle of this is, if you were to multiply these across, you would get dy over dx because both du's would cancel out. So like, I don't remember if I called those u's or v's, but those would essentially cancel out because one's on the denominator, one's on the numerator, and you get dy dx. So an example of the chain rule would be like if you had okay, no, I'll do this. So 3x squared. So an example of the chain rule would be you take the exponent, you put that outside, and then so that's so the derivative of x squared is we'll call 3x equal, I'll call this a of a squared. Like if we call 3x a, the derivative of a would be 2a. So 2 times 3x, because that's x minus 1, times the derivative inside, which is 3. So we would simply get 18x as our derivative for that. And how this applies to the chain rule is that if we call the first derivative, so the derivative of a squared would be dy over dA times, so that's this is the derivative of a the derivative of if of a squared times the derivative of the actual a, so dA over with respect to x, and those cancel out and you end up with dy over dx. Okay. So now on to the last main rule, and then we'll just go into some common trig derivatives that you kind of have to know. It's the quotient rule. So if we have, we'll call this, we'll say if we have a over b or whatnot, the derivative of this, so f prime of x, whenever f of x equals that, would be simply so you have b minus dA dx minus this is this is multiplication. Sorry about that. So minus a times db over dx over, and then you have b squared. So that's essentially saying b times the derivative of a minus a times the derivative of b. Okay. So an example of that, if you had 5x over, let's just say 4x. First off, if we were to simplify this, those x's cancel out and we want to find the derivative of this, we should expect it to be equal to 0. Okay, so we do 4x times 5 minus 5x times 4. And those will both equal 20x, so the numerator equals 0. And that's all over 4x squared, so 16x squared, so that equals 0. So that's an example of that. Okay, now on to some practice problems. So it wants to know the derivative of the function y equals sine x squared. Okay, so we can think about this as sine, oh wait, sorry. I'll do this in a second, but first we need to establish some basic rules. So the derivative of sine, so dy of dx of y equals sine of x, is equal to cosine of x, and the derivative of y equals cosine of x is equal to negative sine. Okay, negative sine of x. Okay, so that's what you need to know. So those are what you need to know for the next few problems. Okay, so we want the derivative of the function y equals sine of x squared, and the square is on the sine, so sine squared. So the squared should really be right there instead of back there. I'll go ahead and change that now. Okay, so we can think about this as sine times sine. And if you remember our product rule, it says that you do the derivative of this times, times this, plus the derivative of this times this. So if we go ahead and do that, we have cosine times sine plus sine times cosine. And what this gives you is 2 sine cosine, which if you know your trig identities, or just your, if you know, are those called trig identities? I don't know. I know that the 1 or sine, 1 equals sine squared plus cosine x. I know that's a trig identity, but I don't know if this counts as one. But that also equals sine of 2x. You can expand sine of 2x into 2 sine of x times cosine of x. So that would be how you do that one. And now on to the next one. We have y equals tangent of x times secant of x. Okay, so what I always do, because I never bother to memorize what like tangent, the derivative of tangent, derivative of secant is. I probably should, but you can work it out, and I'm going to work out here so you can at least understand it conceptually, because I don't like just being told things, I like to understand them, you know. So we can rewrite tan as sine of x over cosine of x. We can rewrite secant as 1 over cosine of x, okay? And if we simplify this, we get sine of x over cosine squared x, okay? So we apply the quotient rule here. So we get cosine squared of x times cosine of x minus sine of x times, and then here we have cosine squared, so we want to find the derivative of cosine squared. Okay, here I'm going to apply the chain rule because I'm lazy and I don't want to do extra math with the product rule. So we can rewrite cosine squared of x as cosine of x squared. And if we apply chain rule to this, we can get 2 times cosine, because 2, you know, we just take the derivative of a times the derivative of the inside, if cosine equaled a, times the derivative, so we take the cosine of a squared, times the derivative of the inside with cosine, which would be negative sine. Okay, so I'm going to go ahead and write that in. Times 2 cosine of x. Now I'm going to go ahead and factor out that negative times sine of x. And then all of that would be over the square of the denominator, so cosine to the 4th of x. Okay, so if we simplify this out, we get cosine cubed. So I'm going to go ahead and, you know, I think I have room. So we get cosine cubed of x plus sine squared x times, 2 sine squared of x times cosine of x. Okay, and all of that is over cosine to the 4th of x. Okay, so I know right now I can factor a cosine out of this original equation, so I'm going to go ahead and do that. Since I'm running out of the room, I'm not going to do the math, so that turns that into cosine cubed. Okay, so now we're left with cosine squared plus 2 sine squared, all of that over cosine cubed x. So those should all have x's. Okay, so here, I know that we already have cosine, so I'm going to go ahead and change this into, you know, we know our trig identity, sine squared equals 1 minus cosine squared, so I'm going to go ahead and do that. So we get cosine squared of x plus 2 times 1 minus cosine squared of x, all that over cosine cubed, right? So that's 2 minus 2 cosine squared of x, right? So those cancel out, so you get negative cosine squared x plus 2, sorry about that, plus 2 over, sorry, I was just looking at, what do you call it, the time. Sorry about that, I was just looking at my answer key, I'm like, man, what am I doing wrong? But I was looking at the key for the wrong problem. So, we'll go, I was doing it right all along, sorry about that. Cosine of x cubed. Okay, so all that's over cosine of x cubed. So here, we can't simplify it down any further. So we're going to break it up into 2 separate fractions. So we get 2 over cosine of x cubed, which we can rewrite as 2 times secant cubed, and then minus cosine squared over cosine cubed. So that simplifies down into secant of x. And this should be of x. Okay, so that's that problem. Sorry about all the pauses and like stuff, because I don't know what I was doing. And now my smooth draw isn't responding. Oh, this has been a terrible video. Sorry about this. Oh my goodness. What is going on? Okay. I think I accidentally pressed the save button there, and I will try to cut it out in the YouTube editing because it takes forever to render, but such is life. Okay, so we will do one last example this episode, and like I said again, I will be making a second episode on this. So yeah. So this example is y equals 1 plus sine of x over 1 minus sine of x. Okay, and it wants you to find the derivative of this, of course. So right now, I'm noticing these are conjugates, okay? And what I can do with conjugates is I can actually multiply by, I could simplify down the denominator if I wanted to. However, I think in this case I will just purely work it out as it's intended to. So we do the quotient, or the quotient rule. So we get 1 minus sine of x times, and then this is a constant, so its derivative is going to be 0. So it's just sine of x. So derivative of sine of x is equal to cosine of x, so times cosine of x. And that's minus 1 plus sine of x times, and then derivative of sine of x is cosine of x, but there's negative, so negative cosine of x. Okay, so if we simplify this down, we've got this turns into addition, and this would turn into addition if I factor out a negative. So we get cosine minus sine x cosine x plus cosine of x plus sine x cosine of x, and all of that is over 1 minus sine of x squared. So I know that these are going to cancel out, so let's cancel out, and we get cosine squared, or not cosine squared, what am I doing? I'm not multiplying. I've got 2 cosine over 1 minus sine of x squared, and then this is its most simplified form. So that's your answer. So hopefully you guys enjoyed this video. If you guys have any suggestions, be sure to leave them below. And also, I have an announcement to make. I am in the process of creating an official study session website, and that will hopefully be live sometime within the next 2 weeks. And it's going to be a great place where you can come on, and if you have questions, any questions for like any math classes, any AP math classes, any AP science classes, you can just come and ask questions, and then hopefully somebody will be able to answer them. Yeah, I'm just planning for it to be like a resource where students can help other students, which will help them improve in the process. But once again, if you guys did enjoy this video, be sure to let me know, and if there's anything you think I could do. Obviously, I should probably freshen up on the material before I make a video, because I did not do that for this one, evidently. But yeah, so hopefully you guys enjoyed, and hopefully it helped, and that's the end of this video.